Okay, we finally got connected. Ooh, that was painful. Okay, good morning. Bit rate's not great. Kind of all over the map here. All right, welcome. This is the nybbles.io daily programming stream, which I run from 5 a.m. to 10 a.m. Monday through Friday Mountain Time. If you want to know what that translates to for your time zone, you can visit my channel page at twitch.tv/nybbles.io. And at the bottom, there's a panel that shows the schedule and translates for different time zones. I'm Jeff, and I have been programming for many moons, much longer than I should admit. Monday through Thursday, we are working on Ryu, the arcade construction kit environment, which is my homebrew development environment idea for arcade, classic arcade systems. Today we're going to jump into the assembler, which is going to be pretty cool, I think, to get that going. Had a little bit of connectivity problem this morning with Twitch. That's happened a handful of times so far. Not sure exactly why it happened. Let's see. Just checking, making sure everything is still stable-ish, and it appears to be so. Let's see. Did I leave? There's not. I feel like going through the news briefly this morning before we get started. So we will do that and kind of ease our way in here. An assembler is something that takes assembly language instructions and turns them into numeric values. So assembly language is a mnemonic representation for what people will call machine code. And machine code is, again, the binary numeric representation of the instructions that a CPU would execute. So on a computer, we'll talk about the simplest case. You have a CPU, and a CPU, the chip, has address lines on it. Those are wires that would connect to other wires. It has data lines on it. So depending on the size of the CPU, it may have 8 data pins on it, it may have 16, it may have 32. Just depends, right, on the size of the CPU. There's other pins, power and IRQs and chip selects and all that stuff. We'll ignore that for now. Just as it relates to programming, so you have a CPU, you have address lines. Those address lines go to, let's just say that there's just one big chunk of RAM. So you have a RAM chip, static RAM chip. We'll make it really simple, so we don't have to worry about refresh cycles or anything like that. And the address lines would connect to your RAM chip, and RAM, is memory, it's read-write memory. So what the CPU sees, most CPUs have kind of a fixed bootstrapping cycle they go through. Especially older CPUs, they may start executing code at address 0. They may start executing code at a really high address with the intention that you'll have like bootstrap code there, and then you'll jump to a lower address. Whatever the starting address is of the CPU, when you power it on, it's going to go to its address lines and it's going to see if it can start reading bytes or words. So a byte, 8 bits, a word would be 16, a D word would be 32 bits, quad word would be 64 bits. The CPUs we're talking about for Ryu, these are all older CPUs, so it's going to go out and it's going to read a byte, from memory, or maybe 2 bytes tops. It's going to look at those numbers, and internally in the CPU, there's a huge map, there's a huge decoder, right? It says, oh, number 16 means load the next 2 bytes in memory into this register. So then the CPU will fetch the next 2 bytes. And then it will put those into its internal register memory. A register is just a little placeholder inside of the CPU. You could consider it a type of memory, I suppose, although it has special behavior associated with it. And then the CPU will execute that instruction. So the CPU decodes the instruction, that first byte that it got. That decoder knows, okay, this instruction needs more bytes from memory, so it goes and gets those. And then it passes that, sets the internal state, and then it passes that information to the execution unit, and the execution unit does something, right? In this case, the execution is to take those 2 memory bytes that got loaded into a cache in the CPU into the register. And then it goes, then it reads the next byte. And the next byte's another instruction. So literally at the lowest level, what a CPU does is read a number and see what that number, if that number matches an instruction that it understands. If it does, it may read a couple of additional numbers for memory, do something. Some instructions write back to memory, right? So then if the instruction's complicated enough and you're going to update something in RAM, then the CPU will actually write data out to a memory location. That's basically it, all right? And then internally, some instructions manipulate the contents of registers, and the manipulations that a CPU can do are mathematical, right? So you can typically integer add, subtract. You can shift registers. That's considered an arithmetic feature, right, in the CPU. And so shifting a register a piece of memory. You have to look at it as binary. It makes more sense. But essentially, if you rotate or shift, you're just moving that binary bit, those binary bits around. And, shifting is going to drop bits off the end, typically. Rotating is going to rotate bits around the end. So it just depends on what you want to do. But at the very lowest level, right, that's it. I mean, that's what a CPU does. So then the assembler is taking people used to, long time ago, when I was a kid, they used to write code in machine language, machine code, meaning that they would sit down and they would write the assembly on a piece of paper, and then they would have a lookup sheet, and they would say, oh, okay, that's this opcode meaning a number. These are the values, these are parameters, and then they would go into a machine monitor and they would literally poke those raw numbers into memory. But that's a very slow, painful process, error prone. So assembly language in an assembler is one level above that, and so you get a nice, clean, textual representation. Yeah, so I'll give you an example of 6809 assembly example. What's this? Here you go. So let me zoom this in. So this is an example of assembly code, right? So the Intel tells the assembler we're using the Intel syntax. The title is just the title that shows up in the listing file. The tab, so when I talk about assembly directives, I'm talking about things like these. These are directives. Public, this is a directive. Segment is a directive. The DSB, this is a directive. So we have a label called temp, right? And we're creating a segment byte, and its value is 1. So this is a variable. You could look at this as a variable. And then there's a segment EEPROM here, which is telling the assembler, hey, we're going to be flashing this into a ROM module. But here's what the assembly language looks like, right? So we're going to load the value, the decimal value of 99 into some registers. We're going to load the decimal value of 0 into the X register. We're going to test the B register to see if some bit, I'm assuming without an operand, this is the most significant bit. I'd have to look up the opcode. And then if the test instruction is going to set a flag, right? And so all the branching is based off of flags that are set in the CPU. And so then if that flag is set, then we're going to branch down here. Otherwise, we're going to jump to a subroutine that shows the number of bottles left. And then the BRA is like a branch always go here. So it's like go to. So then we come down here. And so these are the instructions. So an assembler is going to look at these. These are labels. These are mnemonics, opcodes. These are operands. And these are comments. That's it. Right? And some of the operands, I don't know, let's see if there's some indirect addressing or something. Yeah, there's a couple. Right? So there's some operands, combinations of operands that use memory addressing modes that are a bit more complicated than just immediate parameters. This is an example of one of those. Here's some more. You can look at this as, well, in the case of push, this is not very interesting. This is just multiple parameters. In the case of transfer, in the case of load, this is an offset, right? So you can look at this as like an indexing value. Let's see. Yeah, this example is not too complex, but anyway, that's the assembly language. The assembler takes that, it understands directives, it understands those CPU mnemonics, and then it generates numbers, literally. I mean, that's what comes out of an assembler. And those numbers go into memory, and then the CPU can understand it. So that was kind of a long ramble on that, but hopefully that made sense. Just gonna peruse the hacker news here just real quick. See if there's anything of interest. Not a whole lot interesting going on today. All right. So my first thought is, where should the assembler live? Which right now, I'm thinking the easiest and would just be to put it in core. Putting it in a different library. These all just get statically linked right now anyway. So yeah, I think we'll just plop it in here. So, assembler, the journey begins. My music ended. Yep, sure did. Let's see. So, to kind of repeat the design ideas I had for the assembler, there's going to be one assembler, meaning I'm not going to support like those directives that you saw for 6809 for the Intel assembler. There's different assemblers, right, in the history of these things, and some of them had, slightly different syntax, supported slightly different features. We're gonna cobble together an assembler that has all the features in it that I think we would like, and that one assembler will be able to plug in the different CPUs that we have support for, and the actual assembly work for an individual CPU will get pushed down to a specific plugin class for that CPU. All the directive-y stuff will be handled by this generic assembler class because all the directives will be the same, right, for everything. So that is the goal. Okay, so now, so to kind of understand what we're going to have here, it's important to take a look at parser here first real quick. And parser is a base class, meant to be used as a base class. And this class implements the majority of our parser for us. And this is being used by the command parser right now. It'll be used by the assembler. So this parser has the symbol table on it. It has the ability to parse an expression. So the difference between parse expression and parse is that parse expression, you would give it like 2 plus 2 times 16 divided by 6. It would parse that. It would give you back an AST node pointer to that parsed expression. Parse at the high level is the overridable portion of this, right? This is the thing that subclasses are meant to implement to do their unique parsing, right? Because what the command parser does is different than what the assembler will do, and so the implementation of those needs to be distinct for different implementers of this guy. But then internally, we have a lot of guts, right? So internally, we have the shunting yard stuff. So shunting yard, is it Dijkstra? I can't remember. Let's look it up. Shunting yard algorithm. Yeah, it's Dykstra. The the general idea with shunting yard algorithm is that it's a clever way of dealing with operator precedence, right? So you have parentheses operators and math expressions, and you want to be able to parse those, and you put those on stacks, temporary stacks, and you coalesce things down so that things happen in the operator precedence you want. For an assembler, we're supporting a fairly broad range of expressions, and typically assemblers don't have really complex expression evaluators because they're not that complex. So these internal methods, these protected methods, are here to support the shunting yard implementation. And then we have the core of the parser, so we can clear all the different stacks, the operand stack, the operator stack, position stack, all that stuff. We have the ability to push and pop positions, so as we go through and parse things, if we have to kind of do like a trial and error parse, like so, say we see a token that we believe is the beginning of something, but maybe it's not, or maybe it's an error, we can push our current position when we reach the beginning of that state. We can then let the parser go, and if something bad happens, we can pop our position back to where we were. That's called backtracking. That could either be an error condition or that could be just part of the parsing algorithm itself, because there's ambiguity in the tokens that you're looking at. Line management, we can get the current token. We can forget, like what last position we saved was, and we can move to the next token. We can consume white space. So all this implementation here, all the different little parsers, right? So to parse an operator, to parse a number, and parsing a number this isn't just 0 through 9. This is, okay, if there's a dollar token in front of it, it's hexadecimal. If there's an at in front of it, it's octal. If there's a percent in front of it, it's binary. Otherwise, it's decimal. So there's some complexity in here. And the idea, again, is that all the common stuff is in one spot. We don't have to re-implement any of this. Parsing expressions, right? This is the shunting yard stuff. There's definitely some complexity in here, right? But it's all done. We don't, minus bugs, right? We may have to come in here and fix something because of a bug, but we don't have to fight with it too much. Comments, so either an asterisk or a semicolon becomes a comment, and then we strip out what's remaining on the line, and we actually create AST nodes. We track comments. Ultimately, these typically just get optimized out, but for assemblers, we want to produce an assembly listing file, so we probably want to keep track of all that stuff. So we've got stuff for null, strings, Boolean, characters, all that good stuff. So what we're going to do is we are going to implement this assembler. It's going to be a subclass of a parser. And so I'm going to cheat a little bit. I always like cheating. Cheating's fun. I am going to and actually, I think we should rename this to the parser. Because then we can have an assembler class. Let's rename this, and then we'll create another one. We'll have an assembler that uses the parser. Okay, that makes sense. Okay. So then our parser, and if I look at what I did here for command parser, excuse me, yeah. So we'll just return null pointer here for now, which is we get nothing. Okay. So I'm just thinking here like what our interface on assembler should be. And I think what we probably want is a pointer, no, not this one. We want a pointer to an environment. But we can't make that a condition of creating the assembler. I mean, honestly, I don't think the constructor is going to do a whole lot here. So for now, I will assume that we just get default warning implementations here. So we're going to tell the assembler what environment we're going to use, and on an environment we have the symbol table, right? So that's where the symbol table comes from. C++ 11, I believe, is when the default keyword was introduced. Let's see here. It looks like 11. Yeah. So, a while back. Yes, it did. It really started to change the language at that point. For the better, I think, for the most part. Right, okay, so, and then we're going to have a parser. We're just going to reuse our parser. Yeah, C's kind of stuck with C99, right? Which isn't bad, but yeah, it's back there, back in time. Yeah. Enum support always seems really flimsy in C. It's even still flimsy in C++, in my opinion. They're slowly getting there with enum classes, but there's more to go there. Let's see. So, yeah, it's less about like how they end up getting used and the casting issues between the underlying type and the alias, right? It would be nice if they fix the compiler so that those two worked better. And like I say, like enum classes are closer, but then enum classes are very incompatible with old enums. And, but yeah, oh yeah, iterating over enums would be nice too. Just trying to think of what interface I want here, because so I think, what did I do here? In environment, yeah, so then, I don't know, I'm debating. I think maybe this should just be a symbol table. Yeah, I'm gonna go down a level on this. Ah. Changing my mind. I keep spelling symbol wrong. And then whenever the symbol table changes on the assembler, we also need to tell the parser about that symbol table as well. Okay, I'm happier with that. And I guess while I'm doing this, I'll put this on here. Okay, so then we would tell the assembler about the symbol tip. So in environment, we would, yeah, I think this makes more sense, because then basically an environment has an assembler. Right? An environment kind of represents the same, it's a named collection of state, essentially, that you can thunk in and out from files. So if you imagine, it's like a config file system, sort of, but environment is where everything's running under. So that's a context. So you can switch from one context to another inside of the tool, and then you can have different, that by switching those contexts, by switching environments, right, you can get different symbols in the symbol table. So like in one environment, maybe you have a debug symbol created that will cause certain things to happen. Maybe you have some extra macros defined in your environment script. And those do one thing in a test environment, but a different thing in a dev environment, that sort of idea. So that's kind of what environment's gonna entail. So from a user's perspective, or I guess from the, not a user's perspective, but the system's perspective, everything the user does, commands, assembling, everything is that the environment's the entry point to doing those things. Okay, so now I'm just thinking, okay, so we need an assemble method here, but what am I giving it? I'm thinking the answer here is I'm giving it a project file, I believe. But then I'm wondering if I want to couple those at that level. I'm feeling like the answer might be no. Yeah, okay, so in environment, when we call assemble, we're checking to see if we have a project. So you could make the, actually, let's already do that. Right. So we could get the files for the project, and we could walk them here. And because certain files don't go through this, may not go through the assembler, some would. And we have some ordering too, right? Because do we? Yeah, I think ordering would be important. We would need to be able to sort them. I was born in Elmhurst, Illinois, which Elmhurst is about 20 miles. Sorry for all you metrics folks. Is that like 40 kilometers? I don't know. 20 miles west of Chicago. And yeah, I actually lived in that area of Illinois for most of my life. Spent some time in Ohio, spent some time in Texas, I've spent time in New York, spent some time in Utah, up north in the Salt Lake area, and now I'm down in the southern part of Utah. Yeah, you know, oh, when? Early 70s. Early 70s. I'm much closer to 50 than I want to think about. Yeah, time marches faster and faster, it seems like. Yeah, I mean, my very first computer, I guess if we're gonna talk about the olden days, my very first computer was, my dad was in the Air Force before I was born. He did mostly analog and some digital electronics in the Air Force. Digital electronics was, it's hard to like wrap your head around today, but it was not, it was kind of the new thing, right? And so he wanted to get more into that, and of course related to digital electronics was the whole computing idea. And it was not a foregone conclusion in anybody's mind, right, at that time that you know, computers would ever be anything but these huge dedicated rooms, right, with guys with lab coats that were managing them. If you were in the 70s, if you were a software engineer, which that title really didn't even exist, they were typically called programmer analysts or just analysts. And typically they're not technical. There was no technical background there. If you had history in electrical engineering, then I guess that would be the closest. But oftentimes people who would program computers in this era, they would be, you know, actuaries or accountants or whatever, and they just learned how to do it. So, but anyway, he did a bunch of different study courses, and I remember he built 2 kits. The very first one I didn't actually code on. It was a Heathkit computer, and I want to say it was a Z80, but I may be wrong on that. And then after that one, he built another kit, and when I say kit, I mean they sent you a bare PCB and parts, some parts, not all parts, and manuals that were like 800 pages and schematics, and basically, okay, here's what this computer should be. So there's a company, and they still exist. This company is called Netronics. Let's see. Yeah, here it is. This is the one I was looking for. This was the second kit that he built. Oh, yeah. Sorry, guys. That better? Let me know if that's still too loud. So this was the second kit that he built, and this was an 8085 based machine, and oh my god, now I'm just looking at that page. It says release date 1979, 39 years. Oh my gosh. Oh yeah, I did stuff in CPM. I did stuff in, you know, DOS. I've done stuff on machines that, you know, no one's ever heard of. I did, was it Microsoft had a Unix, believe it or not, at one point. I want to say it was called Xenix or something. Microsoft Xenix? Is that? Yeah, yeah, Microsoft Xenix, yeah. Yeah, I remember that. That's a blast from the past. And GraphNet board. It's not ringing a bell. Do you have a link for something? If I see it, it might ring a bell, but right off the top of my head, it's not. But yeah, back in the day, I wrote stuff on the Apples, Commodore machines, Spectrums, Coleco machines. I did some prototyping on an Intellivision. I did coin-op work, small amounts of coin-op work in the later 80s. Was all custom hardware. When I went to work for IBM, I learned all the IBM stuff. So mainframe, AS400, which they've now renamed to iOS or I something, I don't know. They've changed the name, but it's still an AS400. iPower, I think is what they call it now, which is so silly. But, and then before the AS400, the System 38 and the System 36, tons of Unix derivatives, VAX machines, yeah, you name it. I've seen a lot of stuff come and go. Let's see. So now I'm thinking, sorry, I'm just pondering how I want to. So I guess where I'm stuck a little bit, not stuck, just thinking exactly what I want to do with it is ordering, right? So we have a project, we have files on the project, and you are young, man. Didn't you just say you turned 20? When I look back on it now, like I thought I was really old when I was in my 20s, but I look back at it now and I think, God, I was such a kid. But I had a really odd, my education was a little bit different. I was homeschooled, and I started working pretty young, and so I had a slightly different path than most people did, but still, yeah. My internship at IBM was when I was 16, and I officially started working as an employee, like a full-time employee, right when I turned 18. Yeah, those are some cringeworthy, some of that stuff's cringeworthy memories. Yes, hi Mobile Alpha. Yeah, Heath Kit, man. I mean, That was the stuff. I don't know. See, that's like I just think people that some of that stuff is missing, I think, in today's world. I don't know. That's my take on it. And I realize it's like survivorship bias and you know, just that's what I went through, and so I think it's the right way, but I don't know. I think back in the day we learned things. Yes, it was a little harder. Yeah, it was more painful maybe. But in the end, you came away with much better understanding. I did. So on Discord, and so I'm a total Discord noob, but on Discord, the server is nybbles.io. Unfortunately, because I am not yet an affiliate or partner with Twitch, none of them auto magic. Like, it's linked to my Twitch account, but nothing happens really because I don't count yet in the Twitchiverse. But you can look me up. Oh, it did? Okay, I'll fix it. I thought I did. That's bizarre. Because when I first set it up, it said, do you want this to expire or do you want it to be infinite? And I said, just make it infinite. Let's see. Their UI is cute, but it's also a little bit... invites. Oh, I see. There's two of them out here. How did that happen? Okay. So there's an invite out here. Hello, Mr. Anderson. Can you check again? It says there's a infinite invite out there. If I give you the invite code, does that help? Let me know if that works or not. There was one that was set to expire, but up. I see you. Awesome. All right. So I actually got a little bit confused. So here's an old man thing for you. You know, yesterday in chat we were talking about Discord, and I thought I had remembered it as Discord, and then I ended up Googling on Discourse, which is actually another platform, yeah. So I got a little confused on that one, but I got there in the end. Okay, so project file. What I'm doing now is adding in a sequence number for the project file. This will allow us to control, in the UI pieces, will allow us to control the ordering of files. Now, the assembler is we're gonna have a directive for include. So the way I originally, I guess I was thinking this would work is I would automatically sort like tile sprites, anything that's not source code and data. I would automatically sort those in no particular order within that block to the top of the list. I would assemble them because they all going to have origin directives that basically say, hey, within the virtual memory space of our machine, here's where stuff gets assembled to. But then I just thought, well, you know, what if somebody wanted to have multiple top-level projects in there? Because again, I went back just in my mind. I thought, okay, maybe I'll have a root game file, assembly file that includes a bunch of other source files for the game logic. But then maybe I have a sound CPU, and I want to have a top-level file for that. So that's what I'm thinking of here. And this is going to give us the ability to order files. I should say sort them, right? Is ultimately what this ends up being. Nope. Okay. On the voice channel stuff, just to let you guys know, we'll have to test that when I'm off stream first, or maybe we'll test it real quick towards the end of the stream because my audio setup is a little bit precarious. I have audio being pumped through some separate stuff, so I'm not sure exactly what would happen if I enabled or joined the audio channel at this point. Hopefully nothing bad, but you never know. Okay, so then when we serialize this, we do need to put the sequence out here, and we need to read it back in. There we go. Right. Okay, that looks good. Really? Did I mess up the namespace? Oh. No. Yeah, see, that's why I didn't feel right about referencing environment at that level. Yeah, that's fine. Okay, so yeah, so then I think the right thing to do here this might be a little bit wasteful, but we can optimize it later. Oh, and then I think, what is it? I think it's I'm doing this from memory, so. I think that's right. We'll see. No, that's not right. I can't remember if it. Oh, I bet it can't be constant. No. I should just look at the documentation, but that probably would just frustrate me. Because then it would tell me what that is. Okay, I gotta look at the documentation. What is it doing? Standard sort. Excuse me. Compare. Oh, I had it right. Const reference. Compare the function object, which returns true if the first argument is less order before the second. The signature of the comparison function should be the equivalent to Boolean compare const type reference okay, it says the signature does not need to be const reference, but the function object must not modify the object passed to it. I think this is one of those goofy, stupid. Where auto should work, but it doesn't. Okay, so now it's complaining about first argument const with who's, oh, okay, yeah, so now it's saying it absolutely has to be const, so the documentation lies. Well, for this lambda, I don't think we need any because I'm not affecting the outside closure in any way. It's like a little functor. But see, then if I make it const, it whinges. What was it complaining about here? It was complaining about the constants of the callback. No, now it's all, oh, that's because I made them not be references. Okay, so what is it complaining about here? Oh. Yes. C++ does its job. No, you know what it was? See, this is why as much as I bitch as I'm sitting here and I do this stuff, this is why I love typed languages. I was actually trying to do that inside of a const function, a const method function. That's the problem. Now see, we could argue about how good the error message is. The error message should be better, but it actually was doing the right thing. It was actually telling me, hey, dumbass, you're trying to modify state in the class when you told me that this method shouldn't let you do that. Yeah, so like I'll put this in a non-const function, and life might actually be a little bit better. See, I was trying to cheat. I was trying to say, oh, okay, well, I'll just put this here because then everything will always be sorted. Yeah, see? Look at that. There's just... I'm dumb. Not paying attention. Now, again, I honestly, the compiler needs to issue a much better error message in that scenario. Like, hey, you're trying to mutate state in a non-mutable function, but, yes, definitely human. Okay, so whenever we add a file, we have to sort it. If we're going to do it this way in the mutators, whenever we remove a file, we have to sort it as well. And I will probably revisit that, but for now that should be fine. Okay, so if we have unique sequence numbers, then it will sort. Now, what I had said earlier was environments should always come first, then other non-source files. The order of those is not important, right? So the order in which tile banks and module banks and sample banks and all that stuff get assembled is not really that critical, as long as they happen before. Well, and it doesn't even really matter that they happen before, but in my mind, I'm just thinking, well, it would be nice to assemble all the support data into the appropriate locations in memory before we try to assemble code and run it. So with that in mind, I have this notion. What is my notion? I have this notion that we should have some logic in here that when we create a project file, I guess we pass in the code here. We should have some logic that basically says, oh, okay, if it's an environment, then the sequence number is 0. If it's something that's not a text type, right? Its sequence number is 1, and then text is any number above that, right? Is kind of what I'm thinking. So here comes the switch. So for uninitialized, whatever. So source, yeah, so all these guys here, their default is 1. And environment's default, actually, you know what, environment's default can just be 0. Even though that is the default value, we'll be explicit about it. What the hell? Let's not. Let's go up 1. So environments are always 1. They should sort to the top. Then everything else should sort. And again, within the block of data, tile, sprites, module, sample, background, doesn't matter what order they're in that block. I just want them to be together. And then for source, the default sequence would be 3. Now that we change that, right? We'd be able to change it, but this is just what the default value is. And then for assigning the sequence, I'm thinking if type is equal to object file type, codes, environment, or type is, actually, what the heck am I doing? If type is equal to project file type, codes, source, do that. So I'm not 100% sure if I like that, but I'm going to keep that there for now. The idea here is that you can't mutate the sequence number for environments or the others, right? Yeah, I don't know. I'm probably going to have to come back to that, but this, in the terminal that you're looking at, is WeChat, which is an IRC client. And WeChat is it's open source. So on OS 10, you can install it with Homebrew. On a Unix, Linux, you could use RPM, Yum, or apt to install it. On Windows, I imagine you have to, now that I say that, I don't even know if WeChat Windows. Yeah, it doesn't look like it works on Windows. Sigwin is a suggestion if you want to use it on Windows. So, which is not unsurprising. Yeah, you could compile it, yeah, with MinGW or something like that, I'm sure. Yeah, if you're on Fedora, is Fedora Yum or RPM? I forget. Or is it apt? RPM, yeah. So you should be able to find an RPM package for it. Ah, is it? Okay. Yeah, it's out there. All right, did I compile this? NPM is like a weapon that you use to deploy against people that you don't like. You know, here, use NPM to install. Oh, there goes your machine. JavaScript everywhere. Recursive hell, 25 minutes to update everything. Sorry, don't get me started on that whole ecosystem. Okay, so that's a good question. Here's my guess, and total guess here, because when you enter the realm of the terminal, you are dealing with, you know, it's the control characters exactly. See, you just cut to the chase. Yeah, there's something in your control characters, either in your PS1 or in the actual text that you typed, and when it echoes it back out to the terminal, it mucks up the formatting. Yeah, I've run into those. I actually ran into those problems on a machine I was working on yesterday, and I just had to simplify some stuff so that it wouldn't have errant characters out there. Yeah. Oh my gosh, Mr. Anderson, you're talking about one of my rant topics. You know, I don't know, man. Where do I even begin with JavaScript? I just please, please, WebAssembly, faster, faster. Let us get out of JavaScript land. Let's see. Right. So then yesterday, I raped and pasted no, but I have the path. I don't need that. So yesterday I had raped and pasted code several times, reading and writing streams to files. Then I just realized that, and you know what, it's always going to be text, right? So our project files are always assembly source code. Even for binary data, we're encoding them as assembly source with data directives. So read and write are always just going to be text. And so my thought here, one of these days I'm gonna go see a shrink. You know what? When I write code, I have to have things line up pretty. They have to be all pretty like. Can you help me not be that way? Okay. Yeah. Yeah, unfortunately, I agree. I mean, it's like, um, the control character nightmare is, the pain is real there. I mean, it's not messing up your terminal constantly, right? You can just hit Control C and, or, hit enter a couple times and get to a blank line that's formatted properly. Or is it permanently screwing up your feng shui? See, I knew I needed a second parameter here. Okay, then I'm seeing how. We know we always have to build an absolute path. Okay, so I'm refactoring this. We talked yesterday about there'd be code that we could scan up the parent path to find our project root. I'm putting stubs in place to get to that. So everywhere, like right now, I'm using current path. I'm going to call find project root instead. Now right now it's just returning current path, but at least all the calls will be going to that. And so then when we actually implement that to go up, we probably will end up doing that here because I don't think it'll be super horrible. Right, so now we're only calling current path in that one spot. Everything else is going through the find project route. Yeah, because I just realized I could cleanly factor this. So that's better. And then here, instead of doing what I'm doing here, I am going to call right and use talkback. Well, actually, don't even need to do just passing the string. That's it. That's what I want. There we go. No. Oh, right. Has to be no string too. Yes? Yes. I forget. Do I need to do that? Yeah. Okay. Just thinking here. Check documentation. Close. I think I have some code that we can use to find a parent path, or to search up, I guess is where I'm going with it. Maybe. Oh, okay. What am I? Okay, so I did. That's the mistake I made. I was gonna say, reading the documentation, I'm like, what did I do wrong? That's what I did wrong. That should be okay. Oh, yes, 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 yes. Documentation saves the day. Yes, okay. Got it. So So then, back in environment, now we should be able to say if not file read result source break. So if we can't read a file for some reason, that's bad. Okay. So we read the contents of the file from the file system, and once we fix that find project root function to where it will walk up the chain, and yeah, then it should always find the files as long as we're within the project working directory somewhere. And then we're going to call if not assembler assemble, and then we have to pass in the source. So now in assembler, we will pass in a stream here. And right now, we will return false for it. So we get the files. The files should already be sorted. We will be adding UI to control the sorting. We loop through the files. We have our stream. We read in the stream. So that, that's going to read in the individual source files, populate the stream. We pass that to the assembler. If the assembler bombs, then we're done. Yeah, that's it. I mean, at that level, we still gotta make it work, but excuse me. On the plumbing side, I think that's it. And then okay. I made lots of changes here. You know what I want to do? I wanted to look for all the different places. Okay, so for document load, that's fine. That makes sense there. That's it. Okay, those are the only other places. Perfect. Good. So we consolidated that down. Love it. Yeah. So let's test that because don't want to break stuff we already had working. Okay, so can I do directory listing? Yes. All files that should bomb, load our project. Ah, do I have a breakpoint here? I did. Go. Okay, so project loaded. Load our files. There's our files. Oh, and then, okay, so now let's test our sorting stuffs. If I had like a tile bank, yes. So the sprites and the tiles, they sort up above the source code, which is, so that's our sorting implementation's working correctly. So that's good. And then if we save the project, when we look at the serialized YAML file, we should see I can't type. Yep, so there's our sequence. So environments are 1. Interesting. So our source files are 3, like they should be, but our tile bank and our sprite bank are 1, just like environment. They're not 2. Why is that? I would have expected them to be 2. Oh, look what I forgot. Yay. All right, so let's retest this with the break in there. Good stuff. All right, so they're gonna, I'm gonna remove those. And we'll re-add them. Alright. So new file. Sprite bank 1. Oh, that's gonna be source. There you go. Okay, so now let's save the project. Look at our YAML file here. Okay, so environments are 1. Banks. Oh, yeah. Believe me, I've thought about it. I would like, and there is command history, by the way, sort of. I don't know if you've ever seen me do it, but it's a screen editor, so you can cursor up and you can rerun commands. You can edit it and just hit enter on it again. So there is that, but yeah, there is no command history and that. It's just sort of based on the scroll back of what's in the console. So I'll show you what I mean. Yeah, so those are all 2, and then our source files are 3. Perfect. Okay. So if I go back to Ryu, I can go up here, right, and I can run this again. So if I have a command like ufile foo.s, and we'll say it's a module, right? Actually, we'll do this. Title mod. Oops, wrong quotes. Not mode. Right, run that. I can cursor back up here, and then I can change this to whatever I want. So then I could say level 01 mod, right? So there sort of is a history. And then of course, as you scroll down, right, there's scroll back now. So you can scroll back up to 4,000 lines, 4K lines. Now, every time I run clear, it gets rid of that history. But if I run help here and fill up the buffer, so now I'm on document row 194. So if I scroll up, I can get back to where I was before. And again, this is like the way this is being treated, it's like a screen editor. So if I want to rerun this, I can just change this to 2, right? And then hit enter again. And that's there it is. So yeah, it's not exactly what you were referring to, but there are some things that are there. Okay, so I didn't break anything, so that's good. So this console is kind of an homage to the Commodore 64. If you've ever used the Commodore 64 screen editor, it's kind of the same idea. It's a little unique. Okay, so didn't break anything. Did I get stub filed? I didn't check that, but it looks like the answer is yes, it did. Yep. Okay, so that's working. Okay, so that's good. Now, and so we have assemble, and this is where things start to get interesting. Kinda, yeah. Yeah, all those machines back then, because memory was limited, right? So if you're going to devote 4K or 2K or 1K or whatever to your screen RAM, well, you might as well just treat that as a big buffer then, and then you're not wasting space. In fact, I made this thing look like that on purpose. So, I mean, I'm paying tribute to lots of little things in history, right? So that bar and the way things are quoted, I mean, this is all supposed to kind of sort of evoke the old Commodore, the color scheme, everything is supposed to evoke that model, right? Because to kind of give background, on a Commodore 64, if you had a fast load cartridge, you could use like the $ command on most of them, and that would do like a directory listing, right? And then if you wanted to load something, you could just, go up to that particular file, and usually it was like a bang or it was a % or something. Now this isn't going to work here because mine has slightly different meaning, but like if you list the machines, you'll see me, do this, And that's the way that you used to do stuff, right, on the Commodore 64. So yeah. Okay, so let me just look at this environment here. So assemble, no project, no assembly. Get our files, walk our files, read the file contents, pass it to the assembler. Good. All right, so now, let me commit that because we'll go to the next phase here. Okay, so we added our assembler, and it's pretty basic right now, but we're getting there. Oh, there is one thing I realized I needed to do before we commit this. Right, because the environment owns the symbol table. So we always assign the symbol table from the environment to the assembler. Okay, I just realized when I was looking at the code, I had forgotten that part. Okay, so yes. So in an environment, we include the assembler, and then we add the assembler into our environment, and like we said, assembler, we have assemble, the symbol table, and that's pretty much it so far. The implementation is just stubs for the assemble and then the assignment of this other stuff. We pass the assembler owns the assembler parser. We pass the symbol table pointer down to the parser whenever it's changed. The parser, we inherit from our core parser, and we've got our stubs, right? So parse takes the input, and then parse assembly is where we're going to do the work, and the implementation file, just stubs. We're going to start working on this next. And then our CMake file, just new files that we've added. And then an environment, I think we already looked at this. Yeah, so this should be good. And then the implementation of environment for assemble. So we check for a project, no project, bad things. We tell the assembler, hey, here's the symbol table. Here's the address of the symbol table that you should use from this environment. We grab the file list from the project. We change file a little bit. We'll talk about that. We walk through the files. File now has a read method on it to suck up the contents of the file from the file system for us. So we do that. If something bad happens, we break. Otherwise, we pass the stream that we just read to the assembler. And if something bad happens in the assembler, we break. And then we return back whether or not we were successful. So there's the plumbing for that. Then in project file, we added a sequence field and a getter and setter for that. And we added our read and write methods on file to actually read and write the contents of the file from the file system for us, because that's just much nicer than what we would have ended up doing otherwise. And then in project file, the implementation file. So in load, we check to see if there's a sequence node. If there isn't, it's a scalar. We read that in and we assign it to the file that we just created. When we create a file instance, the sequence value, there's some fixed interpretation here. So any files that are data bank type files, those always just get sorted toward the top, and then environments always get sorted way at the top. And then source files can start at sequence 3 or above, right? By default, they all just sort the same. They'll sort lexicographically, right? After that, we implemented our read, our write. We refactored, instead of referring to the current path everywhere, I added the stub find project root, which we're going to implement here. It'll start in the current directory, look for the .ru folder. If it sees it, then it's done. That's the current root. Otherwise, if we're below that, we're going to go up, 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 up until we find that. If we don't find that, then it's an error, which, yeah, gonna have to think about how we're going to do that. But yeah, we just pass the result in, right? So we made that refactoring to call the stub everywhere. We call write now here instead of reusing that code. And then getter and setter on sequence, and then I put a condition in here in sequence. Basically, again, we can set the sequence on environment files and on databank files when they're created because they have a certain spot in the order. After that, so source files then that we create, we can kind of change the order of those all we want. And then the stub for find project root, and then on the save for the project file, we have to write out the sequence so we can get it back. And then on project, I added sorts. So whenever you remove a file from a project, we resort. And then whenever we add a file to a project, we resort. I'll refactor, make that cleaner, add a sort method or something at some point. But that's a start there. Okay, so let's commit this. And then I am going to go take just like a 2-minute break. And I will be right back. So don't go anywhere, and we'll pick up right where I was at. I might have to brew coffee though too, so. So I was smart this time. I started brewing the coffee when I left. So now it's almost done. I'm learning. All right. Coffee's almost done, and then we'll actually start doing some parser stuffs. Okay. Let's start talking about directives and how we're going to implement this. Any music? Wow, so I appreciate everybody joining and the new follows, so much appreciated. All right, so the assembler. Let's talk about the parser. So what are we gonna do? What does this thing do? I'm sorry. It's probably really loud when I do that. Hold on one sec. I cannot wait until next month when it's like hot and dry again. I can't stand it when the weather gets like this. Okay, so the assembler consists of two things, basically. Actually, I'll say three things. Thing one, directives. Thing two, macros. Thing three, CPU, opcode, addressing, address mode, parsing. Okay, that's basically it. And this implicitly means code generation. So, these first two we're going to focus on a lot to start with, because these are kind of the things that are going to let us bootstrap the rest of the system. This thing we're going to probably eventually shim in. We're going to get small parts working up front, and then a couple of weeks down the road, we'll probably start doing more of this. So the important thing to note is that number 3 is this comes from CPU specific plugin. So the assembler parser here, this is like the master guy. He's going to manage the directives and the macros, and what is my current insertion address and the symbol table and all that. Okay, and then we're going to have a CPU dialect parser or something. We'll have some base class, some interface, and then in the individual CPU implementations, we'll be able to look up based on directives. Oh, this is a 6809. Ask the 6809 for his opcode parser, and then we defer that down to the specific CPU implementation of the parser. So I guess if we wanted to kind of like sketch out what that might look like, we would have a CPU assembly parser. And that would so our CPU assembly parser is going to inherit from core parser. So it's going to be very similar to this. And then down in hardware, in the 6809 area, we're gonna have a subclass of that. So I guess the right thing to do here, we create a new class, CPU assembly parser. And then this is going to be, at least the initial base is going to be very similar to the overall parser. So then we'll have a parse dialect. And then we'll have a override point. So parse dialect will be our entry point at the interface level. And then we will have a pure virtual this is what base classes will have to implement. Or not base classes, subclasses. And I guess, well, no, I'm assuming maybe there's more that we'll have to do in here. I'm assuming there might be some setup stuff or something. So we'll leave that. If it turns out there really isn't, if it's all just going to be in the subclass, then we can adjust that as we go. And then I think I'll do the same thing I did with the main assembler. I will just assume right now that our constructor and destructor are pretty plain Jane. All right. So now, just to kind of continue the shimming exercise, down here at CPUs, we've got the 6809. We'll create a new class and we'll call it CPU dialect parser. We'll just call it assembly parser. I like that. Okay. This is going to be hardware MC869. And this is going to inherit from our CPU assembly parser. And we're going to have our override for what was AST, what was it again? AST node shared pointer. AST node shared pointer on our dialect override. Okay. Okay, so now we have the main assembler, we have the CPU specific plug point. Now on CPU, we need a way of getting so actually on integrated circuit, since that's kind of our interface, we can just ask it for it, so we can have a virtual core CPU assembly parser, and actually, no, I think I'm just gonna so we'll just return a pointer. The class will actually just own it, so we'll just return the address to it from the stack. We'll make this virtual, and this guy, yeah, by default we'll just return null. Most integrated circuits will not have an assembler. And that now I'm debating on the name, because you could, so I don't want to box myself too much into a corner here, in the sense that at some point, like, we might have a GPU type chip or a graphics type chip that has its own little assembly language, and so maybe that particular circuit does have an assembler to it, and it's not a CPU, right? And so this then, starts me on the difference between assembler and assembly. So an assembler is a tool. It's the thing that actually takes the assembly language and directives and macros and all that and turns it into something. Assembly refers to the language itself. So that is a synonym for the parser in question. Yes, so I think that makes more sense. So if a particular integrated circuit has an assembler for its variety of assembly language, then we can get it from the integrated circuit. So then, in that case, now, if we go down to So we have an assembly parser for the 6809. That's the specific implementation for it. That's going to do its opcodes and addressing modes and all that good stuff. The CPU is the integrated circuit in this scenario. So this is going to have a reference to its assembly parser. Just like so. And then we need to override this guy, and we return back the address of our parser. Right, so that's how that all wires up. Now again, they're not doing anything yet, but the basics are there. I might just temporarily move this up. Because that init method is huge. Okay, so now, at a minimum, with our test machine and everything that we have, we can get to all the parts that we need. We can get the custom assembler for it. So that all. Uh-oh. Really? When you're bringing it up in a web browser, or are you using the API? I haven't experimented too much with the Twitch API. I do know, I did read in the documentation briefly that they do have, I think, request limits. So if you hit them too much, and in fact, I think that's exactly what you've got here. I think you hit the throttle. Yeah. Yeah, if you Google and you look at their documentation, I'm almost positive they have a list that shows like what the limits are for the different endpoints in their API. Because I do remember seeing that when I got the OAuth key. What is this complaining about? Cannot define or redeclare because core. I see. Yeah. Fix that. Okay, so all that stuff's plumbed through. Primitive, but plumbed through. So now let's go back to, I have a feeling we're going to do this several times. Okay, so not this one. This one is going to be pretty lame for a while. So we've plumbed that through. And we're going to we will look this up based on the CPU directive, based on like the CPU or component directive. I'm debating on what. So let's talk about directives, right? So these are kind of sort of like commands that we already have in the command parser. The syntax will be a little bit different, but they're similar. So let's talk about what these are going to be. We're going to have an origin command that's going to take an address. And this changes the insertion point address in the assembler, right? So in the assembler, I guess we can go ahead and do that now. We're going to have a uint32t that is the insertion address, and we'll start it at 0. Dental pain is no good. So we're going to have the origin directive. We're going to have, so what I was thinking is we would have like a CPU directive, and that this would be name of component. But going back to what I was saying earlier, maybe it's not really a CPU per se. Maybe it's any of the components that have some kind of code generation related to them. So I think it would be a .component, and maybe even target component. Target / component. I don't know, one of those, right? And I think the name is it's going to be more descriptive. It's going to help document the code a little bit better than if we did IDs, even though everything can be referenced by IDs. Having 101 or 155 or whatever in your source code you're not going to remember what that is. But if you have, game CPU or main CPU or sound CPU, that's going to be more descriptive. And then I think we're going to have a we're going to have a byte directive. So I've debated on these a lot, right? So the data definition directives, there's so many variations, right? There's db. So you've got like db, dw, db, kind of a pattern, or you've got, the old 6809 assemblers would have like, what was it? Fixed constant byte or field constant byte, field constant words. I forget what and then they had RMD for reserving actual memory. So again, I don't see the point in having. I'm retro and I want to try to like capture the fun of it, but I don't want to have to support like 14 different data directive standards. So my thought here is we would have byte, we would have word, and we would have dword. And then after this, you can just, you know, whatever, right? And so on. Yes, we do have Indianness that we have to worry about. That is true. Most of these CPUs, most of these older CPUs are big endian, which is an anachronism now, but yeah, it is what it is. So yeah, I think as far as data directives go, these are pretty close. And then I think we would have an align and a size, right? In case you want to align. Now, one thing I am thinking about that I would like to support are structures. So I think the way that this would work is it would be a struct, a name, and then I don't know, maybe we could use curly braces. I'll put that in here as an initial example. I don't know if I really like that, but and then inside of here, right, you'd have your label and byte or whatever, right? We would need to support dupe. In most assemblers, dupe is kind of strange. Usually it's like size. It's like an infix operator, which I want to try to be consistent, make it simple. So what I'm thinking we would do for size, or for this, is it would be the size, and then in parentheses the initializer, and this could be question mark or a number. Question mark just means we're not initializing it. And I guess that goes without saying too. This could be a number or question mark, right? Question mark would be valid for all those. So we'd have the dupe operator, we'd have struct, we'd have align, we'd have, now so I guess that's the other thing too, is technically I guess dupe is dupe is an operator, the way that it's implemented in most assemblers. Struct is not an operator. It is a data, would be a data directive. I plan to support the following CPUs. So I plan to support those. For those are definitely going to be in the initial release. There's an optional one that I kind of am tempted to. I want to try to support, but it might be a bit more complex. Sorry, I'm trying to find the exact. I don't refer to the CPU as much, so. It's TMS, it's 34020 or 34010? I don't know. I'm trying to find it here. It was the CPU that they used in NBA Jam and several other games after that. Sorry, just trying to find the. Yes, so the other CPU that's a maybe is the TMS 34010. That one's kind of on the high end of complexity. So it's not that we can't do it, it's just that I would like the initial release, I'm targeting like no later than August this year. So that CPU, if we can fit it in, great. If we can't, and then on the sound chips, I'm thinking the Yamaha 2151, the Yamaha 2612, the AY series, and the Poki chip, and might be a couple others. Maybe, we'll see. Maybe a SID chip. Yeah, everything here is meant retro. This is, like I said, again, the year here is 1977 to 1996-ish. That's our range. Hence why the NBA Jam, hardware would be in the mix. So, okay. I guess technically, the greater than and less than are operators for nibbles. And I don't know. I don't think there's. I'm just kind of looking at some references here to see if I'm missing anything. they're not really directives. I guess I keep finding new things. Variables and labels. Oh, yes, we need to support equate or equal. I could see having an alias there for either of those. And then in variables, right, so foo byte is an uninitialized byte variable. Foo that's a label. This would also be a label. So let me see if I'm missing any glaring. So on the expression front, I'm just looking at some documentation from some old assemblers from Motorola and Intel. You know, I support add, subtract, multiply, divide, remainder, division, so mod, bitwise operators. Yep, I do all those. I have dollar, I have percent, I have octal, I have the ASCII thing, so that we support that. Labels, variables. So we, yeah, so these old assemblers, right, so they had like, oh, good question. Okay, so at line 45, this is a variable that is an uninitialized byte. So that means that if I wrote some code like if I wrote some code like this, right, that is going to load the value of that area in memory, right? So let's say that the address here is 0000 in memory. This is going to load the byte at that location, okay? This one here, which is a word, let's say this is at 0100, okay, in memory. This is a label that points at a word in memory. So when you refer to this label, this is actually the address. So this is kind of the equivalent of load effective address, right? So that's the difference. And actually I can't, it would have to be that, right? Because it's a 16-bit value, but does that make sense? That's the difference between the two. Labels are always, the assembler is going to treat a label, the thing with the colon, as a pointer to that thing. Without the colon, then the assembler is going to say, oh, that's a variable, I just want the value of it. So even though you write code that looks the same, the code that gets generated is different, I guess is ultimately where it's kind of a syntactical helper at that level. Okay, so I'm just going through. I will keep these examples because I'm sure we might refer to them again. So the old Motorola compiler for the 6809 had a BSZ directive, which stands for block storage of zeros, right? So this is exactly what my dupe thing does, right? It's size and initializer, and that's it. They have form constant byte, so that was that FCB thing, right? Which we're doing that just with byte, right? We're doing the same thing they're doing with the way our labels and variables work, and the fact that we have these directives. So they have form constant byte, they have form constant character string, which we can do the same thing with byte, right? So this, we could do either, we could have ASCII, which I kind of like this idea, right? Or, I mean, we could also support, you know, we could support something like that too. Right? Yeah, they have double byte, they have a fill thing, so you can just, that's what our dupe does. They have origin, they have page. It's funny, these old assemblers had all these page and formatting options in them because the output that you got was a list file, and you actually would like kind of want to be able to control that. Now I'm wondering, see, I put the, yeah, see, this actually probably shouldn't go there. So what we should have is this here. Yeah. So they have reserve, which is basically the equivalent of a combination of a byte or a word or a D word operator from us with a dupe or with a question mark. So yeah, I actually think on the operator front, that's pretty much it. Yeah, and we're not generating S records or anything like that, so we don't need to worry about those things. So trying to, since we're going to be looking at this for a while, I want to try to make it readable-ish. Okay. So where this leaves us, there's probably some other operators I'm not thinking about right now, but I think for the most part, these are the big ones I can think of at the moment. And certainly the ones that'll get us through like the 6809, the 65816, Z80 for sure, right? Like everything so far we've got on here covers those. So then there's macros, right? And so my thought here was we would have macro, you would give it a name, and then you would give it a parameter list. So param2, whatever. And these are always literal text values, right? So whatever you pass in the assembler gets passed in here unadorned or unchanged. Again, like maybe we would use the curly braces to delineate the block. Because the alternative, if we would be to do something like end macro, which I don't know, I actually maybe like that. Same thing with the structure, end struct. Yeah, I like that. We can stick with that for now. And then inside of the macro, what can you do? Well, I'm thinking we would support .if, an expression, right? .else if, expression, .else, .end if. An expression here obviously has to evaluate to something Boolean. And it's, yeah. So those could be included. I'm thinking that we would have some kind of a loop construct, right? So loop var identifier comma, or actually what we do, loop identifier, yeah, zero for start, end, step. And these can be right. And we'd have end loop. Then I'm wondering, can we just have a general end? Right, just to make the syntax easier. Because why do you actually have to say end struct? Why don't you just say end? So that gets rid of some duplication. So we can have expressions, we can have loops, and then I think we would probably have some here's where we would have some other operators, right? So ltrim, rtrim, trim, substring maybe, paste. So like something like that similar to C. I don't know if we actually need that though, because I think the assembler would just, yeah, upper, lower, stuff like that. Oh, and then going back to variables and labels, I would like to support, so these are global scope, variable, global label. So if I, meaning if I had, it's inclusive, I think would be the, yeah, it's inclusive. So it's, the parser would keep track of what block it's in, right? And so each end that you encounter is for the currently active basic block. So if we had something like loop, and then we had something like if, debug, something like this, right? I don't know, right? So then this end pairs with that, with the if statement, this end pairs with the loop, if that's what you were referring to. Macro names themselves, just like structure names, become global symbols. And macro expansion would just be the name of the macro, right? So if I had a macro, if I wanted to say, load Y with 256, and then I wanted to have like a repeat character macro, right? Oh, you're asking is the loop inclusive or exclusive? I think I would probably make the loop behave like a, it would be like a C loop, right? So it would be inclusive. It's gonna be, so it'd be 0 less than 10, right? It would stop at 9. So it's 0 based. I would keep it 0 based because I think that makes the most sense. People are gonna, and the step would be optional, right? You wouldn't have to have that. It would default to 1. So yeah. So exclusive, I think, is the answer there. So this is how you would use the macro. And like a parameter here would just be that, right? Yeah, definitely we will need to document everything here. I agree. We need to make sure people understand how to use it. So I'm trying to think what else, ifs. So we have conditional compilation, we have a loop. I mean, you can pretty much build up anything, like you could put data statements. Oh, I was talking about local labels. So, like FASM, the flat assembler, like they do this, they have a local directive, right? So I kind of like that. idea that makes things easy. So local directive, so local name, so this would be scope to the current block. That way you can come into your macro and you can say local silly loop, and then you can have, you know, silly loop in here, and you can branch to silly loop, but not in C++. And the assembler will cleverly munge the symbol names when it's inlined so that this does not conflict with the global scope, right? Because that's, I don't know, you know, if any of you guys have watched me using A86, you know, when I'm working on the x86 arcade project in DOS, I like A86, it's great, but and he has a concept of local labels, but he doesn't really control the namespace at all. It's just, his is just if you have like M and then a number 0 through 9, right? Then that's a local label. But the problem is if you have two macros that use M, then they collide, right? That's bit me more times than I care to admit. So I like this idea then of being able to not cause that to happen. So we need that. I don't know. Does anybody else have any things you would want to see in terms of what you can do besides conditionals, looping? We have the data directives up above, so obviously any assembly code, any data directives, right, can be built into a macro. A macro could build a struct, a macro could build data sections, it could build anything, right? So anything that's previously seen here, that will be part of this, right? So honestly, I think this is pretty darn close to what we need. Oh, I see what you're saying. So you're saying in the loop, just specify what the count is, right? So it's more like, be like count, and then optionally start, optionally step, like that. I mean, that actually kind of makes sense. Yeah. I mean, that kind of makes sense. I like that. Because 99% of the time, that's what you're going to do. Yeah. So I can see that. Okay. That's easy enough to do. Do you like, okay, so I don't know if you caught the discussion at the beginning about the dot target or dot component. So again, in our assembly file, I might have an assembly file that needs to target the main game CPU, and that's a 6809. And then I might have an assembly file that needs to target the sound CPU, and that's a Z80. So I want to have a directive that says this is the component in the machine definition that you're targeting, right? So I know what CPU type to go look up, or what integrated circuit to go look up and get the assembler from. And also, if we need to deal with memory map stuff, we can do that there. But do you like dot target or dot component? And then the name of the component from the machine, because I'm kind of waffly on that. I'm not sure which one I like better, but. Okay, so here's the beauty of this, guys. parsing this is actually not going to be that bad. Not going to be that bad. So I'm just thinking, though, there's a couple things we may not have, but it's minor. So we have, the parser has, the parser framework has, so here are all the different operators we support, right? So quite a few. Yeah, I think target sounds better too. We'll go with target. So what I was thinking about on this was, so we have types in our, so the parser supports the following kinds of types, right? A radix number, which is a number, a parsed string that has a radix with it, right? So in other words, when the parser sees a hex number with a $sign or a percent for a binary or whatever, it doesn't immediately just convert that to a, an integer. What it does is it parses out the string and it makes note of what base it was in, so that we can then later convert it and redisplay it. So we have that, we have comments, we have identifier. So an identifier is just a string. And so the identifier really could cover labels, variables, macro names, and that's what goes into the identifier. Identifier T is what goes into the symbol table. That's the, I believe. Let's just double check, make sure I'm not lying. I think that's the case. Symbol dict, which is what? Okay, no, I lied. So it's just a string at that point, which is actually okay. I think that's okay for what we're doing. We do Booleans, we can do strings, we can do character literals, operators, we have commands and comments. And what is a command? I think a command is just, so a command is the spec, the symbol, the size, right? So it's so I think what we want to do is we want to have a directive and we're going to have different types of directives, right? So we're going to have data equate origin target local. Let me do this. Let me split that. So we have data equates or target origin struct which I can't structure. Alignment. If macro. So, got, oops. So let's kind of, got macro, got loop, we got the else block, else if block, alignment, structure, end block, which is generic to anything that needs to end, local, target, origin, wait, data. Those are our directive types. And so we're gonna have types, type, and then we need a data size, byte, word, keyword. So it's actually like, so it's none, byte, word, d-word. And I guess if we're gonna do an ASCII, we might want to specifically think of it that way. I think that's pretty much it for directive. I think it's pretty simple. So I don't want to muck up the order here. I got to put it on the end, because that's one of the small little niggles with boost variant. The only way you can inspect the variant to know which type is in it is an index. So this is 0, 1, 2, 3, so on and so forth. So anything new, we got to put it at the bottom. But that's minor. And then our AST node, we have, yeah, so we would just need to do directive. And then this, I support serializing things, so I can parse it, and then the parsed data can also re-emit itself back out. Where's value though? Oh, there it is. Oh, it's like, what the heck? Yeah, because I think what I did on these others is, yeah, I implemented So then the question is, do we want to be super lazy? And when the parser builds one of these and sticks it on the EST, do we want to just stuff the string in there so that if we have to echo it back out, we can? Or do we want to be, you know, I guess purist, very data driven, and you know, we're going to have a switch on the type, right? And directive.type. See you, Mr. Anderson. Because most of these are pretty simple. Data is really, yeah, we'll just do it this way. This works. So then data is the only one that's a little bit complex. Yeah, so you'll be able to see where this is going pretty quick. No, I think the answer to that is no, but for equates, I'm going to use equal as the default syntax for it, I think. Okay. So now we can round trip our directive from, we'll be able to round trip it back to text if we want to. So that'll be good. Okay. The only thing we don't, so identifiers do not include the colon. So I think the only other thing we need, identifier works for variable because that's what it is. But I think we will need to have a specific token type for label. And yeah, I think that's going to be the case. So label is not going to be exactly the same as these, but it will be close. That's a label. Are these cookies? Oh no, but they're shared pointers. Yeah, no, that's good. Thank you, Sea Lion. I missed that one. Okay, so what do we got? Label. I need to add a label T. Which label? Let's do what is identifier. Where's identifier? There he is. So label is going to be very similar to this, but we have to have a separate type because, again, we're going to have to parse it slightly different than identifier. So really a label will be an identifier plus a colon, right, is what it comes down to. Come on, Sea Lion. Come back to me. Thank you. Right, and then if we serialize it back out, it's just the string plus the colon. And then we got to put that in our variant. Right. And I think I handled it here to serialize it. Yes. And so actually, oops. I don't need to do that here. I can just do this. And so actually, this ends up being true too, and this too, because I followed my own pattern. Okay. And so we have identifiers already in the parser. We just added label, directive. We need to parse. So let's compile this, make sure I didn't break anything. I'm missing is, oh, that's the evaluator. Okay, yep, so we'll tidy that up. So the evaluator, so again, if you'll remember, we can have expressions, right? So we can do mathematical expressions, we can do Boolean type expressions, whatever. So given an AST tree, after being parsed, if you want to actually compute that, if you actually want to evaluate all that out, so go through, find the variables, replace the values for the variables, do the math, get down to the lowest common denominator you can for that expression. That's what this does. And primarily it's used in the console to expand, do the evaluator, right, for the question mark command. So labels, again, they're just gonna get returned back out because they're not, they don't evaluate anything other than themselves. And then we added directives, which also, in the context of the evaluator, And actually, so now, like I'm thinking, right, so the label would behave exactly like identifier, now that I think about it. Yes, I believe that's true, right? Because label will go into the symbol table, and the expression, the expression in the symbol table will actually be the address, the location counter of that label. So that's actually correct. Directive, I think statement here and directive kind of become the same thing. They don't do anything. Just get an empty. Yes, I believe that is true. So let's pile that. I think those are now taken care of. Okay. So let's just run real quick, just to test the the command part to make sure I didn't bork anything there. I don't think I did, but we'll just verify that to be the case. So I should be able to do that. Oh, no, I didn't want to do a and. Although that's fine. I mean, that's, yeah, there I go. That's what I wanted. I was trying to multiply. So that looks good. Symbols, set, foo, 16 times 16. And so that you can see why I have that ability, right, to re-express it as text, because again, in the symbol table, you want to see what the expression itself is, and then if you want to evaluate the expression, then you can dereference it essentially and cause it to be expanded. But yeah, okay, that looks good. Help. List project, list files, load project, list files, list environment. Okay, didn't break anything, good. So now, in the assembly parser, we can start implementing some support functions for some of our new stuff, right? So we're gonna have a I'm going to create a separate section here, and I'm going to call this directive related parsers. So AST node shared pointer, parse directive, and we might end up with some other support stuff there, but for now we'll do that. And then we're going to have label related parsers, AST node shared pointer parse label. And to start with, we'll just have these return null. Like so. And then in the parser, let's go take a look at identifier, parse identifier. So we can already reuse this, right? So the very first thing we can do is, so with labels, right? We could call parse identifier on the base class, and that's going to get us, you know, 99.5% of the way there, except we need to verify there's a colon, right? So if identifier is not null and we need to grab, so we have to parse the token first, then we have to get the current token, and token is not null, and the token is a colon at that point. Now we have a label. Now here's the trick though. The identifier node that we've gotten back is an AST node that's been marked as an identifier node, as an identifier. So that's not horrible. We have to tweak some stuff, right? So the value is an identifier T. We're gonna have to reassign the value. We're gonna have to change the type. So this becomes a label, and we just grab the identifier value to begin with. What is that? Identifier. So value should be a string. Yes. So that should be fine. Anyone happy? No. Because the line's stupid. And this becomes a label, right? So what we're doing is we're reusing, the plumbing we already have for parsing identifiers, and we can review those rules here, but so an identifier has to start with an underscore, a lowercase ASCII character or an uppercase ASCII character, but not a number. It can't start with a number. And if that's true, then we keep going as long as the tokens are an underscore, lower, upper, or numeric value. So, and I think that's perfect, right? That's exactly what we want for an identifier. So we loop through, we build that up, we create an identifier AST node. And then in our assembler parser, we just reuse that. The token has already moved. It's already moved, right? So we've moved to the end, in which case our check for null is gonna catch that, or we've moved to a token that doesn't match one of these, which is true. In this case, it would be a colon for a label, right? And so, yep. And so then if we got an identifier node back, the token isn't null, so we didn't get to the end, and the token is a colon, then it's a label. And we reassign the value right on the AST node to the label T struct, and we reassign the type to label. So there you go. Easy peasy. Easy peasy peasy. Let's just compile that, make sure that works. Maybe it will kick C-line in the pants. What is it complaining about? No viable conversion from, oh, it's already a variant, that's why. Oh, bollocks. Come on. No, don't think about it. Just do it. Yeah, so we'd already had put the identifier into the identifier too. It's in the AST node. It's in the variant. So we had to pull it out of the variant to get to the value. So no big deal. Okay, so now parsing a directive. So directives are even simpler than labels. Now, but with that said, directives are, so it's going to be something really similar to this. I don't think we're going to be able to reuse anything we already have. We're going to have to do it from scratch, but that's no problem because we have rape and paste programming. So we're going to grab the current token. Now see, this is bad here. This is actually a bug. If token is null, return, right? Because I should fix that in the base class because okay, now it's safe to dereference it. So we grab the current token. If it's not null, then we dereference it, and we so here's where this gets a little easier, right? We can say here if token is equal to a dot, because all of our directives start with a dot, then we can move to next token. This condition we don't want anymore. We don't want that. We don't want that. We want to do this. No worries. Yeah, we're making some good progress here on the getting the assembler parser going. I mean, this is actually, for like the core of the assembler, it's actually going to be fairly straightforward. You know, so this is going to be a directive node, and we're going to do a directive T. This is not going to be string-based, though. So we have to do a little bit of magic here. So let me just talk through this again, make sure I got it right. We're going to grab the current token. If it's null, we're going to bail. If it's a dot, which is what we're looking for, then we're going to set up a stream and a temp string that we can use. We're going to loop. We're going to grab the next token. If it's null, we're going to bail. That's bad. And that's actually technically an error. Unexpected end of directive, right? This break is fine, right? Because there's still more to go, and we presumably got some characters. Maybe. I guess technically that depends on, yeah, you know, what we should probably do. We should probably validate that here, right? So directive name is the stream string, which means I have to put this outside. And then we're going to say if directive name length, right? Yeah, is less than 2, then error. So the way this, we create a stream, it's empty. If it's a dot, we're not going to store the dot. We don't care about the dot. The dot's just syntax. And so then we loop, and we try to add up characters in our directive. If we reach the end, we break. If we don't find a valid character, we break. Then we say, okay, is our directive at least a dot plus a letter, or a dot plus an underscore, or a dot plus a number? And I'm actually going to say, I'm going to take the digits out, because I don't think that really, we're not using digits anywhere. So in the directive names, but we are using underscores and characters, that's fine. So if it's at least 2 characters long, then it's probably a valid directive. Otherwise, we bail with an error. And then we make our note. But our note is incomplete because we now need to map the string to the enums that we have, because we're going to turn that string into one of those. So to do that, I will not be lazy. I will not do what I would do and start writing if statements. I will do this. It's going to be directive T types, right? So this is going to be directive to type, and yep, not lazy. So we'll just do directive T types line, right? So I will be a little lazy. I will make a reference here. I'll do this. Do that, get rid of that. Okay. So now I can at least see. So we had so it's all virtual. If you're talking about Ryu, the engine itself, the tool itself, it will run on OS 10, Windows, Linux. If you're talking about the virtual stuff that we're doing, it's old hardware, arcade hardware. So we're going to emulate all that, and it will, again, 6809, 65816, 68000, Z80, maybe TMS 34010 if we have time. So that's kind of, you know, roughly what we're looking at there. Oh, now, so this is interesting. Yeah, I'm not thinking about this right. So this is really, these are from our comment, right? So this is really byte, word, keyword. So this is data, this is data. Yeah, it's going to be, yes, exactly, up to 32-bit CPUs on the high end, right? So align. Oops. Oh, need ASCII. Let me bring up my comment block here. Where did I have it? Is it in assembler, I think? No, where did I put it? It's in assembler parser.h. Okay. There we go. Okay, so now I can go through these. This is more accurate reference. Type origin. Target. And then equate. The equal sign is gonna yeah, that one's gonna be a special case if I'm gonna support that. So we'll do the .eq first, and then we'll swing back around and customize the parser to support the other stuff. And then we have struct. Structure. So I did align, byte, ASCII, word, dword, struct. Okay, I've got origin, target, equate. We're going to come back to operators like dupe and some of these others. Yes, go Game Boy. Grayscale, man. Tiles and sprites. Teeny tiny palette. It's awesome. Labels and variables we're already handling somewhere else. So then we've got macros, conditionals, loops. So if else if else. Local and loop. And macro. Loop, macro. That's it. Oh, end. We need end. Okay. Not too bad. So then what we're going to do is we're going to try to look up the directive type. Directive name, and I am going to boost lower, is it boost? Yeah. To lower copy. Yep. Because you can type, it's going to be case insensitive, because all the old stuff was. We'll just be consistent with that. No reason to be like persnickety on case for identifiers and stuff. So try to look it up. If directive type iterator is equal to the end of that, handle the error condition first. Then we'll bail with an error. Otherwise, we have to and then directive size, data size none. But that's not correct. So we have one special case which I am going to do a switch for. If so, auto data size is directive T data size none. So that's our default. If the command that we got was would Perl be a better language to create an assembler? I guess it just all depends on what you're comfortable with. My chief complaint with scripting languages is that they tend to be write only, in my opinion. You can do stuff maybe faster up front because there's some leverage there. But once things get sufficiently complex, then they're hard to keep track of, and if you look at the code 2 months later, it's hard to, I don't know. I find it difficult to work in a system that doesn't have manifest typing. Again, I can write stuff first, but later on, when I want to change it, it's hard to do. So if our directive type is a data directive, then we're going to switch on, and actually I can't do that. I have to actually do the if else if ladder because I have to look at the text to do this. It's only like 3 or 4 things, so I'm gonna, Directive name is equal to byte, or, oh no, can't do that. This would be data size byte, keyword. Keyword. Or ask. Oops. All right. There we go. So now, so if the directive that we got was one of the data directives, then we look at the specific text of it to say, okay, what was the specific sizing of that so that we can pass that into the initializer for our directive. So, welcome. This is Sea Lion, the IDE you're looking at right now on the portrait display. It's Sea Lion, it's a JetBrains IDE, and it's cross-platform, and I don't know, I have become accustomed to using it. It has its warts, but they are slowly improving it over time. Let's see here. There it is. So this is the IDE that I'm using. I am developing on OS 10, I should say my primary development environment is OS 10. However, the project that I'm working on will run on Windows, OS 10, and Linux. That's the plan. The project that I'm working on is something called Ryu, the arcade construction kit, and the idea is to build a all-in-one development environment for legacy arcade coin-op hardware that existed from 1977 to about 1996, and I'm building a tool that lets you define these virtual machines. It's based on IntelliJ, yes. So JetBrains, right, they built IntelliJ all the way back in the 90s, late 90s, and they released that, and then since then, they've basically refined their IntelliJ platform, and then they've taken the core of that, and they've ripped out the Java stuff into plugins and all that, and then they've made new plugins for C and C++ and Sea Lion, PHP and PHP Storm, and so on and so forth. So they all fundamentally kind of work exactly the same, which is kind of why I like them. Again, not perfect tools by any stretch of the imagination, but decent. Yeah, so there's our parse directive, and I think that's pretty much correct. At least until I run it and it blows up. So then, in our parse dialect, right, parse dialect, that's for the CPU. We'll worry about that later. Oh, you know what? I put this, see, this is my naming conventions screwed me. See, earlier I said, oh, you know, this is what an assembler is, this is what assembly is, and I put it in the wrong spot. But that's okay, we can move it. That's fun. So we're gonna move these to the assembler parser, because I wondered why my comment block was in the wrong spot, and now I just explained why. So yeah, that's no big deal. Nothing a little bit of shuffling won't fix. So assembler parser, C++. There we go. So why I'm moving this is because I put it in the wrong parser. So the assembly parser is the thing that deals with the opcodes specifically, not the assembler level stuff, which is what we're working on right now, the tool level stuff. So I put it in the wrong file because I'm like, why is the dialect stuff in here? That's not right. Okay, now it's in the right spot. That's funny. All right. Yeah, to license, I pay JetBrains a fair amount of money every year to license their IDEs. Yeah, they're expensive, unfortunately. Okay, so we don't need to worry about the assembler. The assembler parser, we have, I just need to change, oops, no, not that. Just need to change this here. There. Okay. Let's make sure that, yep, now it's happy. Okay, good. So we had this parse assembly, which is what I was expecting to see. And so basically what we're going to do is we're going to check, we're going to grab our token. If we're at the end, we're at the end, right? Nothing to do, we move on. Otherwise, we're going to go into a loop and we're going to grab the next token until we get to the end, and we're going to break out when we get to the end. And so actually, this is not quite true. So what we want to do, we want to first, we generically want to say, okay, if there's white space between stuff that we don't care about, eat it, right? Because you could put a bunch of white space and then start writing code. It doesn't, white space is not interesting for us. The next step is comments, right? So is there a comment to parse? Now, I'm trying to think here because what we would be doing, I think we need to add one more AST node type. And I need to look at command parser real quick. Yeah, so yeah, so we need a parent. Let's see here. Yeah. Right. So I had command comment statement. So I'll call this assembly. guess technically we don't want. We just want to walk the children and serialize them back out for an assembly. Assembly is not going to have, there's not going to be a value, it's just going to be empty, at least for now. Maybe we will actually have a real value for an assembly node at some point, but right now I don't think we need it. So what we're actually going to have here is, if there's something to do, we're going to assembly node. We don't have a value actually. And it's a sorry, I'm reading the chat now here. Yeah, I have to agree with Cyanox here. I refer to myself as a software engineer, and I think of that, what that means to me is very much what he said here, right? I try to deal in reality, right, with everything. If you ever end up working on big projects and you kind of have to, there's just rigor, right, that has to go into what you're doing. Now that's not to say that I don't occasionally do things that are looser, right? But in general, yeah, I think you want to be kind of rigorous with what you're doing. Hence why I prefer like C++. I prefer a statically typed language, not because it's not an aesthetic reason, it's more of a functional reason. It's just, I know I can reason about it better, so I can schedule better, and I can I can just get things done more consistently. Yeah, static manifest typing. So if I say static or manifest typing, I mean strongly typed, yes. It's not a duck. It's not a duck. Well, but auto is, so a directive like this doesn't have anything to do with typing though, right? This is just type inference, right? This is a string. I know it's a string. The compiler knows it's a string. This is just saving me from having to type things over and over and over again, right? So that's just, I don't know, that's just logical, right? That's just syntactic sugar in my mind. The language should support that. Okay, so we have our parent node now, and barring unforeseen issues, that's what we're going to return. Yeah, I mean, auto to me is one of a handful of things that C++11 introduced, and they did correctly, right? I mean, I thought they did a great job with it. So white space we don't care about. We're going to look to see if we have any comments. If we have a comment node, then we're going to add it into our parents' children list, right? What are you complaining about here? It should be fine. Stupid C line. Sometimes, man, sometimes. So, if we have comments, so I think the real answer here is we want to say token is equal to current token. We don't want to move. But we do want to say, hey, if we're at the end, then bail, right? Because we want to let our other tokenizers move us through the stream appropriately. I have no idea. What is it bitching about? No, that's easy to fix. Because I added assembly in here. It's complaining about. I thought I included you. Go away. Fix the evaluator. They should go down there. Should go down in the do nothing block. There we go. Okay. There are different integrated circuit classes that handle the different implementations of the different CPUs. And then earlier, so there's an assembler parser, which is what we're working on right now, which is the top level part of the assembler. This is handling directives and macros and things like that. Then there's an assembly parser, which is the assembly language. And I actually think I'm going to, because I made this goof now twice, I think I'm going to rename this guy to that. I think I'm going to say assembly language parser. Right? So this is the dialect parser, and then the integrated circuits, of which CPUs are a subclass, they provide an assembly language parser instance to us that we can use. So based on the target directive that we use in our code, we know what CPU we're going to in the machine, and then we can go pick up the correct dialect parser. But all the directives and everything are going to be constant. They're not going to be shared, or they're not going to be dialect specific. They're going to be neutral, common to everything. Okay, so I fixed the evaluator. This is just C Lion. It's got to catch up and be smart. So comments, we're going to slurp those up, stick them in our parent node. Excuse me. Then I think the next thing would be, okay, is there white space? And is there a directive node? Or actually, you know what? No, let's not do that first. It would be identifier, right? Node, or label. So it could be one of those. So this is a case where we would have an AST node, shared pointer, label node, pointer. Actually, I don't know if I need to do that. So that's what I want. So we try to find an identifier, which would be like a variable, something like that, macro name, whatever. If we don't find that, we try to find a label. We're going to have to do, we may have to do backtracking though. Yeah, see the identifier. So here, what I'm thinking about here is that, so we have a position in the parser, we keep moving to the next token, the next token, the next token. But so like let's say you start parsing an identifier, okay? But then you get to the very last character and it's colon, and that's not valid for identifier, so it's going to, that's an error. But what we really want to have happen is we still want that, we want to be able to reparse that, essentially. So, yeah, what we have to do there, if you remember in, we have the ability to store and reset position in the parser. So we have a stack of positions. And so what we can do is we can push the position, and then if we end up in a if we fall out here for whatever reason, interesting. Yeah, how are we going to do that? Because really the condition, it's not the condition here is not what's important. So here's what has to happen, right? We're bailing if it doesn't match our regex. What we really have to say is if the current token is, can I have a white space? There's white space? Okay, I'm just using his space. All right. So yeah. Oops. Back in parser, really what we want to do is parse identifier. We want to say here is if the current token isn't null and it's space, because that's the only, for an identifier, is that true? No, that's not true, because of parenthesis. So we could go the other direction with it. We could say if we have a token and it's not a colon, right, because that's our special case, then we can go ahead and do this. We have an identifier. Otherwise, it's a label. We want to go back and position and try again. So, do we have a token to work with? Nope, bail. Push our current position onto the position stack, start parsing the identifier. If we fail, if we bail out of here, and we ended too soon, right? And actually, this is, that's an error. So unexpected end of identifier. Otherwise, you don't need to do this test again. As long as the current token we're on is not a colon, then we have, because the other characters are already accounted for in the state machine, then we have an identifier. Otherwise, if we fall through, we pop our position back, we return null. So now it will try to parse an identifier. If it's not an identifier, then we wind back and we try to parse it as a label. And then, and we can talk about optimizing that later. Yes, it's a little inefficient. It's doing double the work, but we can think about ways to optimize those things at a different time. And then, so then if we have an identifier or a label node after all of that, then we're going to add it to our, right? Because I'm just thinking about how assembly works, right? So white space, we don't care about white space for the most part, right? Obviously in strings and stuff, that's taken care of. But do we have comments? Find a comment on a line and, you know, suck up that comment. And the way I think parse comment is written, yeah, the current character we're on has to be a comment character. So it's not that we're going to go find comments. It's that if we're on a comment, then we get a comment. Otherwise, we try to suck up any additional white space. If there is none, then we try to get an identifier or a label. And if we do get one, then we put that in the parent node. Then we try to consume white space again. And then the next one would be a directive, right? So do we have a directive node? Then we parse the directive. If we have a directive node, then we're going to put that in our child list. Like so. Do I do any unit testing? I assume is what you're asking, like programmatic unit testing? No, not really. Have I done unit testing? Yes. I find it of minimal value usually, especially with something like this. It's yeah, it's a lot of extra work, and I don't know. That's kind of it. Unit testing is one of these philosophical topics that can very easily, like, if it makes you feel comfortable to do it, then I would say do it. But if it doesn't, if you have this feeling in your gut like I do, that it's just kind of a waste of time, then yeah. And here's the thing. Like when I first wrote this parser, the foundation of it, did I have like a little test class or a test function that would take some input and push it through the parser and get some output and test it? Yes, I did. But once I got past it working, and I was kind of satisfied that it was doing what I wanted, then I moved to more of like a functional integration type testing environment. Because I don't want to pay the price to have to keep those unit test classes and everything happy, right? So here's my thing, okay? So I've been around long enough and I've seen enough that I can tell you this story. It's a pretty short story. Oh yeah, I've got bugs. Do I encounter tons of bugs? No. But I would say every day I fix a bug or two here or there. But it's not like I have thousands of bugs. I don't know. Does anybody else agree that, or disagree that I have like a high occurrence of bugs in the code? I mean, I know I have bugs, but I don't think I have excessively high occurrences of bugs. The one thing that I will say is when I do hit a bug, I fix it, right? Like or if I'm not going to fix it at that moment, I will comment, I will track it in the code, right? So that I know it's there and I can go back to it and correct it later. But here's my story on unit testing. So a long time ago, I did a lot of Smalltalk development, and I like Smalltalk. It was neat. It had a lot of tools around it, just because of the nature of what Smalltalk is. And you have to understand that what we call unit testing or test-driven development today came out of the Smalltalk community. It came from Kent Beck, Ron Jeffries, Ward Cunningham, Chet Hendrickson, a couple other guys, right? Michael Feathers. These guys were all Smalltalk programmers. That's what they did. That's where unit testing came from. Now, if you've ever done anything in Smalltalk, and if not, you can download, what is that free Smalltalk environment, Squeak. You can download Squeak, you can play with it to kind of see where I'm coming from on this. Smalltalk is so terse and it's so abstract, and there's tooling, literally tooling around everything, that to write a unit test for a Smalltalk class is very lightweight. And the Smalltalk environments had, and still have, really complete and very powerful refactoring tools built into them, again, because the language is very simplistic. And and there's no compiler, right? There's no translation step, there's no make, there's no MS build, there's just the stuff that everybody else has to do, right? That you don't have to do in Smalltalk makes a big difference. So this whole idea of I'm going to create a test class in a class browser in Smalltalk, and then I'm going to add a test method, and then I'm going to have it try to new up an object and do something with it. That's like seconds to do that in Smalltalk. As where, in C++ or Java or C# or, you have to create the files, you have to build it, it makes it a little bit slower, right? And that stuff just builds on top of more, builds on top of more, builds on top of more, right? So eventually what happens is, unlike in Smalltalk where the cost, right, stays manageable, right, up to some point, in a lot of other programming environments, the cost becomes prohibitive. And this is the other biggie, right? Smalltalk is uber reflection, right? Uber dynamic, you can execute things by name and symbol, and you can look stuff up anywhere. There's globals in the image, right, that you can go. There's a global that tells you all the classes in the system. There's globals that tell you all the instances in the system. You can go do anything you want, right, in a Smalltalk image. It's literally like one line of code away, basically, for anything that you want to do. In a typed language, a strongly typed language like a Java, a C#, a .NET, or a C or C++, you don't have that, right? You don't have this all-encompassing image that has all this metadata about everything, all the windows that are open, all the, Smalltalk is literally its own world. So in strongly typed languages, you end up with all this dependency injection, and you end up with all this extra cruft that you need in order to be able to decouple everything at a type level so that you can then test it cleanly. As we're in Smalltalk, you could do a lot of that stuff without having to build any plumbing, right? And so that's my long-winded story of basically saying that I think where unit testing came from and what everybody in the Agile, where unit testing is now, the world it came from is never the world it ended up being used in. And I've always seen them as being very disjoint. So it's very expensive to do it outside of some very specialized environments, like Lisp. You can do unit type testing in Lisp very easily. Again, but it's an image-based world. It's a different world. So, okay, so we have our directive node, and and so then the next thing, right, would be to consume some white space. I can spell, and then expression. Parse expression. And so an expression is going to be a string, a character, a number, an actual expression of 2 + 2 × 6, whatever. It's going to be a full expression. A Boolean, null or nil, a whole wide variety of things. So expression node. So at the very basic level, right? Now, here's where things get interesting, right? We need to do more in directive because we have a couple here that start a block, right? So we have to add a scope stack. And directives that create a new basic block need to push that scope onto the stack, right? Because, so what's going to end up happening, right, is like if you do a dot macro or a dot if, that needs to become the new parent that everything else is going to get streamed into. So we have to address that. That's not currently being addressed here. And that won't be massively difficult, but we'll have to do it, right? But this code should parse non-basic block structures, right? So we should be able to do equates, targets, origins, data statements. Now the data statements, we're going to have to, it's the expression parsing, right? Like, so right now we could do dot byte and we could have an expression, or dot word and an expression. I have 4 monitors at the moment. 2 that are on my main desk here. The 2 that you're seeing in the stream, I have 2 that are behind me. The split that you're seeing is coming from a tool called Wirecast. So Wirecast lets me take inputs from a variety of different sources and lay them out as the format for the stream, and that's what you're seeing. So yeah, what I see are actually different monitors. You're seeing those combined. So we're actually coming up here to the end, and I'm going to have to break right around 9:45 my time here today. So let's review this real quick, and that should get us right to about that time. And then tomorrow we will actually be able to start pushing. We'll get it wired up so we can actually start editing code in the source editor properly against the project, and then we will be able to actually start pushing code through the assembler. So I'm just double checking my CMake list files here to, yeah, I added a bunch of stuff. And, no, too long. Put it there. There we go. So that's nice. And then in core types, we added our directive struct and a lot of implementation for that. And then we added our label struct because we want to treat labels, even though labels and identifiers are nearly identical, we want to treat them a little bit differently. And we added our directive and our label structs to our variant, and we added our token types. We added a type for assembly. So the assembly type, just so you know, that's like the program, and maybe I should call it program, I don't know. And then I added label and directive. And then in the serialize for the node, I added in support for assembly and for label and directive, so that those should all go back and forth properly if we need it. Might come in handy for debugging purposes. In the assembler header file, we added the location. I originally had the location, I was calling it insertion pointer. I originally had that in the assembler. I moved that, or the parser rather, for the assembler. I moved that up into the assembler. We're gonna have to figure out exactly how that state's gonna be managed, but really that belongs to the assembler itself. The parser, we spent quite a bit of time talking about what our assembler is going to do, at least at the base level, right? So I put comments in here to kind of document what we're trying to hit, and then we implemented parse label and parse directive. So we got that far. Parse directive is going to require a little bit more effort, but we're close. And then in the assembler parser, so we have a map that maps the directive text name to its type, so we can look that up after we parse it. We have the parse assembly, right? So this is the program. This is the whole, here's the entry file. Anything that's in here, this is what we want to be assembled. And so we implemented this, and again, this is like first cut. It's gonna need a lot more work, but we'll get there. And then we have parse label, which reuses a lot of parse identifier. We have our parse directive, and again, this handles, I think, the base case, which is like 80%. We have our new assembly language parser, and this is the interface for the CPU or the device-specific assembly language, right? This is the assembly parser. That's the high-level tool. This is the thing that individual components would implement to provide their own dialect. And then we have the 6809 version of that. And yeah, I might rename, well, I'll rename that later. And then in CPU, we added the ability to return back. We override the interface that integrated circuit offers to give us the assembler that this device will use, right? So that's how we do the device specific piece. And then the CPP file just returns back a reference to the parser that it holds. And then the evaluator, as we added new things to the AST node, we had to support those, right? So labels and identifiers, they get treated pretty much the same way. Assembly and directive, right now they're a no-op. Eventually, for directive, we might, I don't know, we'll have to see. Actually, we will. Like, directive will eventually be handled in the evaluator because, like, for a macro, that's going to become an expand. For a conditional, that's going to become a, that's going to return back one of the correct basic blocks recursively, which then would be evaluated again. And so then in integrated circuit, we added a virtual method called assembler, and the default does nothing. It just returns back null. The base doesn't have an assembler, but then components that we implement that do have an assembler, they can return whatever variant of assembler they need to return. And then in our parser base class, which is where like 90% of our parser lives, some bug fixing and some adjustment. Parse identifier, we had to handle being able to backtrack properly, and I think that was actually the only fix this time around for that one. So I think I changed a couple files. So let me just make sure that builds. Okay. So I'm just going to consider that a checkpoint. I'm going to push that up to the old GitHubs. And I think that's where we're going to end today. By the way, can anybody tell me really quick? I noticed that somebody did a bang uptime, and I've seen that in other streams. What do you need to do to actually get that stuff to work? Does anybody know? Okay. Do you have to write your own bot? Or are there already bots that I could get and set up? Or how do people typically do that? Okay, I'll look that up. All right, guys. Hey, thanks everybody. Yes, bots for Twitch. Do you have any recommendations, real quick? Because I'll look those up later today if I have some idea of what to go look for. Okay. All right, I'll look those up and then I'll go from there. But yeah, I can probably get something set up for that. So awesome. Thanks everybody for dropping by. Really appreciate it. Tomorrow we're going to continue on with the assembler. We're going to get even more done. because we've kind of got the foundation laid now, and I think we'll be able to get into a test adjust cycle, and yeah, it's gonna be awesome. We're getting there. So everybody have a great day, and I will see everybody tomorrow morning. So